talk is how programming in other languages made me a better Ruby developer. Thanks.
Oh. I actually had some jokes ready, like I wanted to be the first one saying goodbye from Philippines, but I guess that's not going to be valid anymore. So every once in a while I generally do like a kind of thing before starting a conference. Today I think I already know who's the winner, but I want to do that in any case. So please raise your hands. I want all of you to raise your hands, and then I will start counting from today, like 2017, going all the way down. And when you stop writing Ruby code, so actually keep your hands raised until you're like writing Ruby code done here, and when the year is gone, just like pull down your hands if you're not writing Ruby code in that specific year, right? So when I start, all of you raising your hands, and keep your hands raised if you were writing Ruby in 2017. Okay, good. 2016, who was writing Ruby in 2016? Oh, a lot of hands. 2015, okay, 2014, 13, 12, 2011, 2010, 2009, 2008, it doesn't count, 2007, 2006, oh, ooh. 2005, 2004, actually, okay, 2003, okay, we have like almost winners. Yeah, I mean, you shouldn't play this game. That's not fair. So, congratulations to our like winners and to our unique, super amazing winner. Good. So we actually have people like were writing Ruby code in 2004. So you can see 1993. You can see how we went along with this language, which is pretty awesome. But the language also changed a lot during these years. And I also think that us as a developer, we change a lot. And in fact, the talk I'm going to give you today is how my code, how my habits as a Ruby developer changed during the years. It's going to be a slightly technical talk. So some of you in the very last lines, maybe you want to like step a little bit forward. I actually checked the code and it seems to be quite readable from the background. But yeah, so the slides will also be online, so you could be able to check them later. I work for DN Simple. We provide domain management services, so we do domain registration, SSL certificates, DNS hosting, everything through the API. We have amazing mascot and stickers, so feel free to reach me later if you want some stickers. We actually have Ruby stickers here. I left some of them yesterday, they're all gone. I still have some of them. I also have chocolate, if someone wants chocolate, so feel free to reach me out later if you want to talk about anything. Or if you just want to get some chocolate, it's fine, I won't be offended. So just stop me and say, hey, I want to have a chocolate. Actually, sometimes I throw that in the audience, but... So, I consider myself a polyglot programmer. I really love programming languages. I've been programming in 15 different programming languages over my career. And as you can see from the, is it magenta? No, it's not magenta. As you can see from the main color here, I've been programming in Ruby for quite a while, although recently I switched to, partially switched to other languages. The blue here is mostly Go. In 2000, I was here in RubyConf 2016, actually in Manila, and if you were there, you probably remember that one of my slides was about being influenced by other programming languages. So this year, I wanted to bring that a little bit to the next level and talk about how other programming languages influence my design. And so to me, learning a new language is like essentially starting, living for a journey, starting a journey. When you pack for your trip, you don't really know what you can expect, right? But it doesn't matter. I mean, it doesn't matter what's going to happen. No matter where you go, when you will come back, you will be different. You will have learned something new. and you will come back having grown as a person. Now, some of those information might not be extremely useful, so I don't know, I knew on a trip on Hawaii that pineapples grows on trees. I actually didn't know that. That was awesome. Now, how you're going to use this information? Don't know. Well, maybe put it on a slide, but I don't really know. But the point is that, you come back and you learn something new that potentially is going to change your way of your habits. In my career, so I generally distinguish between established versus emerging languages. Established are languages that has been there for a while, and emerging, I actually consider the word emerging as an adoption, not really as a age of the language, because some of the languages here, like Haskell, has been around for years, like decades, right? They're not really emerging. Same thing for Erlang. Erlang has been there since the 80s, actually even before, but has been emerging lately thanks also to, for example, Elixir. So some of those emerging languages may actually give you some new hints on how you want to improve as a programmer. Now, to me, my major influences in the last 5 years has been Go, Elixir, Java, yes, Ruby, Crystal, and Prolog. So I want to show you how some of these languages improve improve the way I write Ruby code today, and I'm going to do that one line at a time. So we're going to go through some refactoring. The first thing I want to talk about are structs. As you can see, I will show you a little icon about the language that mostly influenced this pattern or idea or refactoring. So in Go, for example, we have structs everywhere. Like in C or in other languages. And structs are a way for you to pass around data. Whereas in Ruby, we're all used about having, for example, active record models that mix into data and behaviors. So this is, for example, an active record model. As you can see, you have some kind of information there, but you also have a method like refresh that changes the inside state of the object. And that can be really unhelpful, especially when you have maybe to test it. So let's take another example. Oh, by the way, all this code is actually, all the examples except one are actually real code that we were running in production or in some open source code or other jams. So here you have an example. For example, this is a library that was interacting with a registrar. Let's focus on a few things. So here you have some static methods that are doing some operations. And then you have other class instance methods that are performing state changes and running other kind of operations. Now, as you can see, we have mixed responsibilities here. We have some operations that are acting on an instance, although they don't really require an instance at all. In fact, the renew can totally be a class level method. That forces you, for example, to send a request whenever you want to renew a domain. The first one to allocate the object, like to create the object, like fetching from somewhere, and the second one to execute it. There's also no symmetry, no apparent logic behind this design. We can change, for example, renew to static, and we're going to say one HTTP request. But that's also not only the thing. The thing is that this object is actually also a domain model. It's a model itself. It contains information mixed with behaviors. So then we forgot that Ruby has structs. So what we have been doing lately is moving a lot of data responsibilities to data objects. So the structures that only hold the data, and then you have other objects that perform the execution of the business logic. So in this case, for example, this is how the code may look like before, and this is how the code may look like after. So you have a struct object that's gonna just contain the data and pass around the data. So you can safely pass around this object without even having state change on the inside. And whenever you wanna mutate information inside the object, you just create a new one and you return the new object, so you don't even have side effect. And it doesn't really, it's not just that it seems more clear, it's actually more clear. And this is, for example, a metric result of the evaluation of the code of the library. As you can see, most of the code changed from D, the worst one was E, to A. So the code, actually, by running static analysis of the code, you can determine that if technically much better. So separating data from logic, from execution logic, actually is going to bring you a lot of benefits, especially in testing. You have no state changes, meaning that you have really loose couple between the data and the operation, so you can test them independently. And talking about stateless business logic, this is a topic that actually deserves a full explanation. And oh yeah, I was not looking at that. I couldn't see the language there. This is mostly inspired by Elixir, because Elixir is a functional language, and so in functional languages, you don't really have, you generally don't have states inside and no mutable object. As you know, Ruby is not a functional language. It's although it has some functional language features, and you can partially use it as a functional language. And I will show you how there's a benefit in doing that. So the first thing you can see is that here we have an example, again, an example of a typical combination of objects. You have, actually I can see from here, so let's switch here. I'm sorry, I'm jumping it back and forth. You have an account, you have an order, and it's quite common to see a lot of code, like a lot of processing code. Again, you have operations and you have data inside the same model. But then you also have models like the account score that's going to call external services. And calling external services, so sending out HTTP requests from a model, is really dangerous because you can't really test it really well. So let's focus on that for a second. Let's mention that the score object, the score method inside has some kind of operations, and then perform a change of the state of the account. Now, how can we improve that? So, for example, we can have, first of all, we never use active record in this case, but generally speaking, library methods outside the model here, because we don't want to have like update attributes all around our code, because otherwise we'll be tied to whatever the framework is providing us. We want to have full control of the implementation. So what we generally do is that we expose a custom API, in this case update score, which is also more meaningful, and we can test it, it's more powerful. That's the first step. So the next step is, let's create an account service. You can call it service object, but we don't really call it service object, mostly because there's a lot of confusion around the idea of service object. Anybody talks in a different way. It's just a kind of library that we, like an implementation that we use. So we have an account service that is mostly functional style, never perform, has never stayed on it. And we have a store account method there that takes all input, changes the input or make any change, and then returns an output. So as you can see, we have a score account there, and the first step is just like placing the score account here without making any change, right? So your code will continue to work as it was before. You simply have injecting a kind of hook. The next step, as you may have guessed, is to move the implementation of the score account outside, right? So again, small steps, refactoring, you can keep on testing, and you make small steps at a time. Okay, so now we have a bunch of things left outside the account, but we're still actually calling the implementation inside the model. So the next step is to move away from that idea and completely remove any non-persistent related changes from the model itself. So at this point, we have that the account model is just going to deal with persistency. And the business logic, so the idea of how the scoring of an account is going to happen, is inside a separate object with all the responsibility. And as you can see, the separate object is taking an account and performing changes on the account. Actually, there's an issue here. It should return an account, and I'm going to talk about that in a second. But now let's focus on the order. As you may have guessed, we can keep on going on this refactoring by creating an order service, start abstracting and taking out the implementation of whatever is not specifically connected to persistency, and then we have a process order outside. We do the same thing that we did before, but also now look at the order services and how, depending on the account service, so what we can do is that we can start dealing with dependency injection, which is going to be a topic I will talk in a few seconds. And by doing that, we decouple the objects and the classes, and it will be much easier to inject, for example, a test dependency and avoid testing a specific implementation by sending out or mocking out hundreds of HTTP calls. This is how our autocontroller looks like now. As you can see, I'm just calling a service and calling the main method that I need and passing the order, so passing the main data information, and that's going to return me the change data information. And then this is how the account looks like, and this is how the order looks like. No more methods that deal with anything else except persistence. And then we have a clean list of business-related executions in our dedicated object that we can test, and we can easily see what our application is doing. So the benefit of these changes, the reduced side effect because caused by states, improving test effectiveness and code maintainability, simplify tests by using context setup. We don't have to set up a bunch of connected objects just to test one specific method in a model. Slim down model objects, removing third-party interactions, and then expose the business logic in a centralized place with clear and easy to test methods. So focus on maintainability. And so I mentioned the function-like thing. So you might be interested to know that even like programming languages that are functional, they are not like pure functional. There's very few pure functional languages actually. And as I said, there's nothing wrong in bringing some functional patterns into the way you use Ruby. One of the main benefits of functional languages are that there are no states. So you pass an input, and given the same input, you are always expected to get the same output. So predictability, and you can test it. It's really helpful. There's no side effect inside, so it reduces the complexity of your code. And now, what here I want to suggest as a functional-like approach is essentially, as you can see here, we have pretty much the code that you were looking before. We have an execution of an order, and so we have a service. In this case, we use a register pattern to get an instance of the service, but it doesn't really change anything. The point is that the order service is essentially a service, and then calls the process order with a data object and returns the data object. And that's exactly what I mean when I say like functional-like approach. The functional-like approach to me is like getting an input, and that can be one element, can be like 10 arguments, and returning the output of the execution. So, is it redundant? Yes, it may seem so, because you can change the state of the order inside the method and not return anything. So what is the value here? Why are we going to increase the complexity of the verbosity of our code? Actually, I would say verbosity, not complexity. Well, the reason is because if you make the change in the state here, you don't return anything. Let's have a look at what's going to happen in your test. Now, this is a typical test. You have an expectation on the class and then receive a process order. But because the implementation changes, like the state of the order changes inside, how do you return the modified object in a way that then you can set expectations based on the object? How do you do that? You still have to make changes to the object, because otherwise you won't return the object in the state that you're expecting. And in fact, by making the change that I was suggesting, you can actually create a data object that contains the information that you want. Because remember, you're not testing the execution. In this case, you're not really testing the execution on the object. You're testing whether your controller behaves the way you expect when you're testing data. So in that case, you can literally construct the object that you expect to return and return it, and then you can set expectation in there. So for example, you can set an expectation in the direct, because now you have an ID of the object. So what are the benefits here? Well, you can simplify tests by being able to better isolate dependencies. You can improve your unit testings and really use integration tests just for comprehensive coverage. As you probably may have guessed, integration tests are a little bit slower than unit tests because they actually connect more pieces together. And you can speed up your test by not having to test unnecessary code changes due to internal state changes. Let's jump to another topic, which every time I mention dependency injection in the Ruby community, they are like, oh, what's that? This is actually a topic that as a Go programmer, I started to love and embrace. And the reason is because Go has a long history of dependency injection. If you have been using the app engine for a while, you will remember that in the past you were not even able to use any HTTP library, but you had to use the HTTP library that Google was providing. So essentially you had to swap the HTTP library dependency in production. And the way you did that was by essentially injecting the HTTP library in production code. Now there are actually some benefits in using the dependency injection. Also, keep in mind that all these suggestions, if you push them very forward, you may actually start abusing them and have terrible code. But there's some benefit in using dependency injection in your Ruby code. Let's have a look at here. This is the only example that is not yet a real example. It's a coffee machine. Let's pretend to be a coffee machine. As you can see here, I wanted you to focus on the specific section of this coffee machine. Specifically, I wanted you to focus on the use of the machine object. This is a really common example. You know, you have a machine instance variable, which is lazy evaluated, which means that the first time we call it, we instantiate the object. And sometimes we even do some HTTP calls to the outside. Now, what is the problem here? Well, the problem is that it's really, really unpredictable and hard to test. Let's have a look at how a test can possibly look like. You start by setting an expectation for any instance of the coffee machine, because you have no control on how that specific instance was created. And then you expect to receive a prepair with some data and return some other data. But again, you don't really know what that instance of the coffee machine looks like. So there's a lot of mock in here. And so let's have a look at how we can potentially improve decouple the implementation of the coffee machine from the external service. So the first thing that we can do is that we can pass the dependency as an option in the constructor, right? So you're going to be explicit. Now, again, Ruby developer tends to be afraid of writing code. Hey, damn it, you're a programmer, you must write code, right? So you pass the explicit dependency in the initializer, and then you have the instance that you know and you expect, and you set that immediately on the constructor. Now I've started to embrace also keyword parameters for this kind of refactorings because they work really well, and also they helps reducing some of the issues with hashes. Most of the time when you start passing options as hashes, you're really confused because at some point you don't really know which options are passing, especially if you have a lot of layers. So here we are passing the dependency straight on in initialized time. Notice that this is actually not pure dependency injection. I will talk to that in a second. But once you do that, the benefit is that you can create and you can pass your coffee machine object in the text. So you know what object you are creating and passing. And so let's look at the code here. And what you can do is that you can actually get rid of one entire line of mock. Now, if this doesn't seem a lot to you, it's because you don't have a code base which is 7 years old with hundreds, if not thousands of mocks. So by doing that, you will actually improve your code a lot because you will set expectation on objects that you know and control directly. But there's also another benefit here. You can actually completely swap out the coffee machine class with a custom object, like a test object or a no-op object. That's going to do anything else except performing a really lightweight execution and potentially save the information about methods that were called somewhere than you can expect. So you can actually have no-op object or test object. Now I mentioned that this is not pure dependency injection because in dependency injection actually you have to pass the dependency all the time. Here we are using a default. So technically another way you can do that is by passing, pretending telling the Ruby interpreter that you want to have an explicit dependency here. And that's how you can say that, machine colon empty. And so Ruby will complain if you don't pass the parameter here. There's nothing wrong, as I said, in like taking some of the inspiration from the outside and model them based on the language you're writing. The benefits that you can get here is improve the coupling, simplify the test again, and increase the maintainability and effectiveness of your code. This is another interesting challenge that I learned from other languages that are a little bit more complex, or used in like a little bit more complex ways. I'd say in a lot of layers. So, for example, Java. Now, there's an interesting thing here. Let's have a look at this code. This code performs some execution and then rescues the error and tries to handle the error. As you may see, we're using a custom error, and this is real code that we're using in our application. There's a lot of layers in between. Now, let's have a look at how the library is internally implemented. As you can see, we have a custom error. Then we have the main validation error. Both of them are inside the model, like inside the domain of our Let's Encrypt library. But then we are raising an argument error that as you probably know, it's from the Ruby core library. It's not really anything inside our standard library. So this code here will actually not catch it. So how should we do that? Are we going to like start rescuing a lot of exceptions from all the different libraries? It's a really good habit to generally try to keep everything inside the scope of your library. So what you can do here is we started to introduce module error tab. What you probably don't know is that you can actually rescue exception based on module inheritance. It's like labeling, tagging your exceptions, and then you can rescue them. And this is really cool because you can then change and say like the Let's Encrypt error, which was our error before, like our base error, is now inheriting from the standard error, but it's also an error of the domain model. And then we have the domain validation error, and finally we have a custom argument error, which extend, like include the error, and so it's part of our model. And the way you can use that is by swapping the argument error with the new custom argument error. So your code will still behave either like it's an argument error or it's an error of the class itself. So what you can do is that you can rescue a specific error from your library, or you can have a fallback rescue from any exception which is raised from your library. And this is a really, really good, I would say excellent approach for a library designer. You should always raise exceptions that are only originating from your domain model, because otherwise you will force users to start rescuing exceptions from like everywhere, like timeout error, and then socket error, and then net error, and so on. There's also a benefit here. I don't know how many of you, this is a really Java-oriented thing. I don't know how many of you knows about the COS implementation that was introduced, I think in Ruby 2.2, if I'm not wrong. So essentially, have a look at this library, at this example here. I'm rescuing a timeout error in my custom library and raising an error which is from my library. Now, what's going to happen here is that the timeout error is going to be attached to my custom error. And I can access it by using the code, and unfortunately it doesn't seem to be really well documented. And so what's going to happen is that I can rescue my error, and I can print out information about my error, but I can also then access the original error, which was the timeout one, and I have all the information about that. So there's sometimes people will complain that by rescue and re-raising, you are actually hiding the information about the original error, but it's not true anymore. So you can totally do that, and you will preserve all the information. So by doing that, you will facilitate your error handling by exposing just one single model to the outside, and you will repackage the exception, giving access to the original error, so no information will be lost. One of my last final topics, programming without default. This is really something that was mind-blowing to me. So I have a question for you. What will happen, what would you do if tomorrow Ruby would drop default parameters? I mean, how your code will work? how many times do you create methods with default values? Like this is a typical example. You have an execute method with a task, and then a category can be a default, and then an action can be can have a default. But then you start going to the cases where you want to default the last parameter and not the second one. So you have to set the default to the default and so on. Now in Go, there are no default parameters. You can't do that. There's no way you're going to do that. That's actually a kind of a workaround. And so the way you do that is by having explicit struct that's going to store all the options. So all the options will be there. They will be explicit. You won't have to guess it. We often use hashes, but again, then you don't know the hashes which options can have, right? And so your code may have a bug because you're expecting the hash to be a string. And so this is simple. How many times that happened to you, right? No way. In Go, you create, for example, this is a list domain. This is the API client that we provide in Go. You can check it out. The code is open source. And then you have a domain list option struct, which contains the information about the domain list. And you have kind of extend the base list options that contain all the list option parameters for example, pagination. Now, if someone is going to look at your code, it's going to be immediate which kind of options they are passing or they can pass. This is a typical example. It might seem ugly to you. It's actually lovely, especially if you've been maintaining a large code base. This is how we can create a domain list options, passing the options explicitly. There's nothing wrong with that. And in fact, I wanna conclude by bringing you one message that's really, really important to me, which is the value of simplicity. And specifically, I think I already mentioned that last year. There's a very, very mind-blowing talk by Rob Pike, one of the creators of the Go programming language, which is called "Simplicity is Complicated." And so it goes through the challenges of keeping a language simple, which it's actually more complicated than just stuffing a bunch of features and then inside the language itself. Features are complexity, we want simplicity. Features hurt readability, we want readability. Readability is paramount. This is something that you really should think about your code. I really encourage you to have a look at this video. This is really, really interesting. That was Go in 2015. And one of the use cases that we have in our code was alias. Alias is an amazing feature, but it's often really, really abused. We misspell really often name servers in our code. We'll sometimes name underscore servers, and other times we'll name servers all glued together. And so we're like, you know what? We're tired of mistaking it. Let's just alias the code. And so we eventually ended up having tons of different ways to call the same thing. And then we had models that sometimes were camel case and other times were not, because of the byproduct of having names like the same concept called in several different ways. And in fact, one of the code policies that we have is that there's no more alias in our code. You can't use alias. No way. Yeah, that was a real example. That was really bad. And so having a single, clear, simple API, it's really paramount. It's really important. You can go here, look at what the application is doing, and even for a newcomer, it's going to be really helpful to understand how the application is behaving and maybe focusing on very simple stuff. So we have seen, I hope you are still with me. I know it's an intense topic. We have seen like inspiration from other languages. Specifically, I got a lot of inspiration from Elixir that introduced me to the functional languages, although I used like other functional languages in the past. But the syntax is really close to Ruby, so it's actually a little bit more readable than, for example, Erlang, although after a while also not readable. And then we've seen a lot of examples coming from Go, which I generally say it's like programming in C, but having fun again. So I really encourage you to check it out because it's a really interesting language. But what I want to tell you here is that I'm not going to suggest you to switch the language. I'm actually going to suggest you to embrace those languages as a way to improve how you write the Ruby code today, especially if you're still if you're actually a Ruby developer
and if Ruby is your main programming language. Because as you have seen, really often it's not the responsibility of a library. It's not a library which is bad. Most of the time it's the programmer that is using a specific feature in the wrong way. It's abusing it, and so think about that. And yeah, thank you very much. I don't want to raise it further, so I don't know if we have time for questions. If not, I also have chocolate. Actually, I need to say one because I think I'm going to drink a warm.
Maybe.
So I need to say some chocolate.
Maybe chocolate for the ones to ask questions.
Okay.
Yeah, we have time for questions.
Oh, okay. Oh, right. Yeah. Okay. So who's gonna? I also know some of them has rum. So who wants some chocolate with rum?
I'll let you know.
Okay. But you need a question. Oh. That's a deal.
Actually, he's a Christian.
Hello, it's nice to meet you. I'm gonna get there. You're gonna get your chocolate. Don't worry. One way or another, you're gonna get it.
I'll be fast. Can I have chocolate?
There you go. Sorry you missed that.
All right.
That was a good question, though.
So my question was going to be,
How can I buy a DN Simple t-shirt? Is that even possible?
No, unfortunately I don't have the simple t-shirts here. I actually have the simple stickers. So you can have that.
Oh, I'll still put some stickers. I'll come and see it over.
Sorry?
Stickers would be great.
Okay, I have them. I will give you them.
Awesome. Thanks, man. That was it.
Oh, sorry, I destroyed our computer.
Hello.
No.
So you have
No.
you've chosen this update score method. You've picked a boundary of what your active record model should do, but how did you decide kind of where those boundaries were? Because you still open an API to your active record models, but you only go so far. What?
Right, so the question is essentially how did we decide the boundaries of what's going to stay in the active record and what's going to go outside? Is it correct? Yes, sure. Okay. So the way we did that is essentially by ongoing experimentation. This is the result of more than 5 years of development. And it's not even defined in stones yet, right? So we keep evolving our code. And also we have to deal with legacy code, which is an issue. I mean, we can't stop here and change after 7 years old code base just doing refactoring all the day. So we start by looking at what was complicated to test and to maintain. And then we started like thinking about changes. And in fact, one of the main issues that we also faced in the past was premature abstraction. You know, like pretending that we already know where was the problem and extracting out the problem. And the first abstraction that we did was by moving into mid-syncs, because that's what most of the people do. And so there was a question about concerns, and I usually say like concerns are concerning to me. Because you're just like hiding the dust under the carpet, you know, you're not really cleaning the house. So we slowly went through what was the issue there, issues that were not easy to test, issues that were not easy to maintain, or code that was breaking in after refactoring. And so that was part of it, and the other part was just looking at other languages. Go had really changed our mind of pasting code, because you have no mock libraries there. So you suddenly change from a language like Ruby, where RSpec and mockup are encouraging you to mock all the objects, to a language where actually there's no mocking going on. Pretty much like you're jumping from a language like Erlang or Elixir, where there's pattern matching. So you are destructuring an object at function definition level to a language like Go, where you don't even have default arguments, right? So like, it's a mixed approach. This is what worked well for us, and so far I'd say that we are pretty happy with that, and it's solid. So we haven't changed that in the last 1 year and a half, but we are now like going through making sure all the code base is following these patterns because we still don't have that everywhere. Now we are now expecting other changes, like I was saying yesterday, like using events, for example, instead of like logging straight off from libraries. So there's other areas of improvement that we are working on.
Okay, thank you.
One more question from that?
Okay, so it's like, how long does it take you, let's say you want to learn something new, to kind of just randomly do tutorials on it and start reading about it and talking to people about how they're using it, and then you take it further and create a project with it, or just bring it right into your existing apps, or I guess, I've started a lot of things, but I always kind of stop because I'm like, oh, it's so different than what I'm doing at work right now. It's hard for me to like finish something, so I don't know certain times how people learn a lot of things.
That's actually a really good question. So the question, if I understood correctly, is how you approach a new technology or language, because the most common issue is that you start dealing with that, but then it's so far away from your like, daily job that you actually don't see any, you can't move forward, essentially. So yeah, that's correct. Now, there's a couple of things that here. The first one is that you really need to pick, to set a goal, right? So a learning goal, which means like build an app, write something, or make something that has specific clear goal. Because if you're just hacking away, you're not going to make any progress in that. You will like learn, read something, try a little bit, like, play a little on the console, but then at some point, when your interest of the initial high will fall down, you will stop doing it, and in less than a few weeks you have forget everything. So the way I personally do is that I pick a specific need. I actually pick a technology. I try to understand, or a language. I try to understand whether what is the like best use for that tool. And then I try to see where we have something in our application or in my daily job or in any other area of interest that I can apply that. And actually I'm really lucky because in the Simple we encourage that. So for example, one of the examples in 2012, we had a director, so what like picks a domain name and then forward you to some other URL that was created in Ruby, but then it was not able to handle all the requests anymore. And so we started experimenting in other languages. We went to Azure, we were in Java, and then we eventually tried in Go. And all that process was actually a learning process. So the redirector was a very small application, now 140 lines, but it was a clear goal. And we spent some time experimenting with that. And we did the same thing in other cases, like rewriting the API client. We wrote the API clients for our consumers. So we don't only expose the API, but we also expose the client. And the first client that we had was Ruby 1, and now we provide 4 official clients: Go, Elixir, Java, and Ruby. And I actually have a talk online where I explain how Go guided our development design decision. And like writing a client for me was actually the way I really improved my Go skills, because I had to pretty much re-implement and reinvent how our clients were built. So pick a specific project, a small project, something that you can time box and focus on that. Just not like try to like play around or hacking it, because eventually you're gonna lose the interest in that. And the second thing, really short, is eventually you'll get better. It's like learning new languages. If you just pick one language, the second one is going to be hard to learn. But if you actually speak 5 languages, like learning, I don't know, if you speak French, learning Spanish is going to be easier, because you have to sort of like adapt to the model, but some of the key topics you already master them. Also, you have the flexibility to understand it. That's pretty much like it is. If you already know 2, 3 programming languages, going to another one, it's going to be much easier, and sometimes even like more fun than the first one. Actually, the second one may get better. Thank you.